AutoCAD is a premier 2D and 3D drafting tool used in a variety of fields, from architecture and engineering to landscaping and interior design. Originally created to replace drawing boards, it has two distinct working areas represented by different tabs: the Model tab and Layout tabs. The Model tab is where you'll do all of your actual design work, as well as place the vast majority of your annotations. In the drawing I have here, you can see that I have the floor plan for a 2-story building drawn at a 1:1 scale. For designing, this 1:1 scale is great, but since the main purpose of AutoCAD is to communicate the design to others, the scale is restrictive. Instead of recreating different parts of the drawing at various scales throughout the model space, however, I can simply set up scaled viewports in the Layout tabs. I'll switch to one that I've already set up, and you can see that it has a viewport zoomed into the men's washroom with a scale of 1 to 20 listed on the title block. The viewport itself is simply a window into the model space, meaning that any updates made there will be displayed here as well. This setup also means that you can create as many Layout tabs as you want, focusing on any number of different elements without having to worry about updating them. The Layout tabs can then be easily printed and plotted for collaborative work. Taking advantage of this structure allows you to spend more time designing and less time updating. Before we get into how to create drawings and layouts, I want to get you familiar with the AutoCAD interface itself, as well as introduce you to some of the terminology I'll be using throughout this course. To start, I'll go to the Application menu, shown by clicking the red A in the top left of the interface. From here, you'll find ways to create, open, save, import, export, publish, print, and close your drawings, as well as adjust the current drawing settings. Any option with an arrow can be hovered over to show additional commands, but if nothing is being expanded, a list of recent documents will be displayed here. To the right of the Application menu is the Quick Access toolbar, which gives easy accessibility to some of the more commonly used commands, such as save and undo. The drop-down on the right edge of the toolbar allows you to customize what is displayed on it, as well as gives you the option to show or hide the menu bar, which has more traditional File, Edit, and View drop-downs if you want to work with those. To the right of the Quick Access toolbar is the title bar, which displays the name of the currently open drawing, followed by the info bar. From here, you can quickly search the help database, access your account, the App Store, and the AutoCAD community, or view the full extent of the help and feedback options. Below all of this is the AutoCAD ribbon interface, which is broken up into tabs, panels, and commands. Right-clicking in black space on the ribbon allows you to change which tabs are displayed, which panels are displayed in the Active tab, as well as undock the entire ribbon. Individual panels can be undocked by simply clicking and dragging, and many can be expanded to show additional commands by clicking the flyout, which can be pinned open if the panel is docked. Right-clicking on a panel allows you to change which tabs or panels are showing, while right-clicking on an individual command includes the option to add the command to the Quick Access toolbar. Beneath the ribbon are the Drawing tabs, which give quick access to the Start screen and Open documents. Hovering over an Open Drawing tab displays a quick preview of all of the Model and Layout tabs in the drawing, allowing you to open directly to the selected tab. The large open space is the drawing area, and is where you'll be interacting with your design. It will change a bit depending on if you're in a Model or a Layout tab, but otherwise functions as your canvas. Right-clicking here will bring up the context-sensitive shortcut menu, which will display commonly used commands based on what you've selected and what command is active. On the right of the drawing area are the View cube and Navigation bar. These allow you to move about the drawing, and will be covered in more depth in the next lesson. At the bottom of the drawing area is the command line. Typing in the command line will give you access to all the commands available in the software directly, and once a command is active, will update with prompts on how to use it. Additionally, it keeps a record of what actions have been taken during the session, which you can show permanently by expanding it up, or temporarily by pressing F2. Much of the command line's functionality can be echoed next to the cursor if the dynamic input drafting setting is active, which it will be throughout this course. The drafting settings can be modified by typing D settings and using the Drafting Settings dialog box, or turned on and off by clicking on the icons in the status bar in the bottom right. Clicking the rightmost option on the status will bring up a list of the settings stored on the bar, with checkmarks identifying what is currently showing. Finally, the bottom left of the interface shows the Model and Layout tabs, with the Active tab displaying in bold with highlight. The plus icon to the right allows you to quickly add a new default Layout tab, but note that there can only be one Model tab in a drawing. Now that you have a working understanding of the user interface in AutoCAD, I'll next cover how to navigate around a drawing. There are a variety of commands that you can use, but the most common 3 are bound to the scroll wheel, so I'll start there. The first command I'll cover is Zoom, which will zoom into the drawing centered at the cursor by scrolling up, and zoom out centered on the cursor by scrolling down. You can customize how much each tick zooms by adjusting the zoom factor variable, but for now, I'll leave it at the default 60. The next command is pan, which allows you to move across the drawing at the current zoom level, and is done by clicking and holding the scroll wheel while moving. Finally, zoom extents will set the zoom and pan such that the drawing is centered with all objects showing, and is done by double-clicking the scroll wheel. While these three commands will let you move anywhere in your drawing that you want, you can get additional control by using the commands in the navigation bar on the right side of the drawing area, or in the Navigate panel of the View tab. Starting at the top of the bar are the navigation wheels, which are selectable from the flyout. I'll activate the full navigation wheel, and when I move back into the drawing area, note the wheel that follows the cursor. This wheel gives a huge variety of zoom, pan, and orbit commands, all of which are used by clicking and holding on a command from the wheel. If you don't like how much space the wheel takes up, you can select the flyout in the bottom right corner, or right-click on the wheel to switch to one of the mini wheels. Additionally, the wheel can be closed using the X in the top right corner of the full wheel, or through the right-click menu. Moving down the navigation bar, the next option is the single pan command, which, when selected, converts your cursor into a pan hand. Left-clicking and dragging will use the command, while right-clicking will bring up the shortcut menu, from which you can switch to a few of the other navigation commands. Note as well that the command will stay active, making every left click a pan, until you either switch commands or end it by pressing Escape, Enter, or Spacebar. Next on the navigation bar are the zoom commands, most of which are hidden in the flyout below the most recently used command. There are a lot of zoom commands here, including zoom, in, and out, but there is one in particular that I want to cover before moving on. Zoom window. I'll select it, and the command line prompts me to specify the first corner of my window. For the moment, I want to zoom in on this second-story restroom, so I'll place the first corner near the restroom and pull away to get a preview of the window. Clicking again will define the window and zoom so that everything inside it is showing. Some of the geometry outside the window may show depending on your screen size, but zooming like this is a great way to quickly get onto a specific section of your drawing without having to bounce around zoom levels with the scroll wheel. Back in the navigation bar, the next options are for the 3 orbit commands. These are primarily used for working with 3D objects, and will allow you to move in 3 dimensions around the point you select. Since this is a 2-dimensional drawing, however, the orbit was less than helpful. Trying to manually get back to the true top-down view with a manual orbit could be done, but it will be much easier and faster to use the view cube. Located just above the navigation bar, the view cube is also the most helpful with 3-dimensional objects, but note that it has a compass surrounding it, which can be helpful in some architectural or landscape drawings. To use the view cube, you can click and drag on it to get an effect similar to an orbit around the current view's center, or you can select a face, edge, or corner to look at the drawing from that perspective. Since we want a true top-down, I'll select the top view, and the drawing is back to where it was. If the rotation was off, you can use the arrows in the top right that only appear when looking directly at a face to rotate the view in 90-degree increments. The last option in the navigation bar is Show Motion, but since it's concerned with animation, which is outside the scope of this course, I'll skip it. Finally, the flyout on the bottom lets you customize the options shown in the navigation bar, as well as change its docking location and link to the view cube. There are a few ways to start a drawing in AutoCAD depending on the template you want to use. If you simply want to start a new drawing using the most recently used template, you can do so by clicking Start Drawing in the Start tab, or by clicking the plus sign at the right of the Documents tab. If, however, you want to use a different template, you can do so by selecting one from the Templates dropdown in the Start tab, by clicking the New icon on the Quick Access toolbar, or by selecting New from the Application menu. When one of these options is selected, it brings up the Select Template dialog box. From here, you can see each of the available templates, as well as navigate to anywhere on your computer or server to find other templates. For this lesson, I'll select the ACAD.DWT template and click Open to start a new drawing with the template. At this point, I can start designing in the drawing with the settings saved in the template. Each template can have different settings for units, layers, drafting settings, styles, layouts, and page setups, but these are never set in stone. The units can be changed by going to the Application menu, hovering over Drawing Utilities, and selecting Units. The layers can be changed from the Layer Properties Manager found in the Layers panel of the Home tab. The drafting settings are all stored in their own dialog box, which can be accessed by right-clicking on a setting and clicking its settings, or with the D-Settings command. Styles are stored in the Annotation panel of the Home tab, and everything about the Layout tab can be found and altered by simply going to the Layout tab. Finally, page setups are adjusted using the Page Setup Manager, which you can access by right-clicking on any Layout tab and selecting the option. In this way, you can use the templates as a base, and then fully customize your drawing. If you find yourself making the same changes consistently, you can create a template of your own by simply saving your drawing as an AutoCAD drawing template file with the .dwt extension. Once you've got a drawing open to a template you want to use, the first thing I recommend you do is set up your grid and snap values as well as your limits. Like all drafting settings, they can be changed once you've started drawing, but I find them most helpful when first starting a drawing. The grid drafting setting controls the size of the grid you see here, and can be quickly toggled on and off by clicking its icon in the status bar, or pressing F7. To adjust the grid size, I'll right-click on the icon and select Grid Settings. This brings up the Drafting Settings dialog box open to the Snap and Grid tab. The grid settings are displayed on the right and allow you to adjust its style, spacing, and behavior. Notice in the Grid Behavior section that Adaptive Grid is checked. This will actually scale the grid up depending on your zoom level. So if you want the grid spacing to always display the same, you'll need to uncheck this option. Any value can be typed into the spacing, but notice that the X and Y value will always update together to stay square. To use a non-square grid, you'll need to set these values to 0, which will then use the snap spacing values here for the grid lines, even if snap mode is off. When snap mode itself is on, it will restrict the cursor to the snap spacing while a command is active. Note that this spacing doesn't need to match the grid spacing, though I tend to find it a bit confusing when it doesn't. For this lesson, I'll set the snap spacing to 0.5 for the X spacing and 1 for the Y spacing, while using a grid spacing of 1. I'll click OK. Make sure both drafting settings are on by making sure their icons are blue, and enable the line command from the Draw panel. I'll zoom in a bit, and notice that the mouse jumps around the drawing area according to the snap spacing I set up earlier. I'll press F9 to turn off snap mode, and the cursor is once again free to move anywhere. With that setup, I just need to define my limits. Limits in AutoCAD will define your drawing area, and what zoom all zooms to, but it isn't restrictive unless you set them up to be. Let me show you. To define them, I'll type limits and press enter. I'll type 0, 0 to define the lower left corner, then press enter, and define the upper right corner as 20, 20. I'll use the zoom all command to zoom to the limits. But notice that they aren't easy to see. To get a visual idea of where they are, I'll bring up the grid settings once again and disable Display Grid Beyond Limits. Now when I press OK, you see exactly where the limits are. By default, this is just a guide, and you can still draw outside the limits if you want to, which is great for notes. If you want to restrict your drawing abilities, however, you can do so by re-enabling the Limits command and selecting On from the command prompt. Now if I enable the Line command and try and place a point outside the limits, nothing happens. Taking advantage of the grid, snap, and limits can really help keep your drawing focused and to scale as you get started. Now that you have your grid and limits set up, you're ready to start drawing. All of the basic drawing commands you'll be using to create objects can be found in the Draw panel of the Home tab, but keep in mind that it may be quicker and easier to launch the command from the command line or dynamic input. Most of the drawing commands in AutoCAD are easy to use with clear prompts in the command line, so in this lesson, I'll focus on the different input methods available to draw accurately. The line command is great for this, so I'll enable it by clicking on its icon in the Draw panel and then move into the drawing area. The prompt in the command line asks me to specify the first point, and the dynamic input next to the cursor displays the same prompt as well as the current coordinates of the cursor. I'll place the first point by clicking, and now when I move around the drawing area, a line is anchored there. Notice as well that fields for the length of the line and angle from the first point are now displaying instead of the cursor's position. These prompts are generated from dynamic input, so if I show it on the status bar and turn it off, they vanish. I find these prompts extremely helpful when drawing freehand, which is why I always work with dynamic input on. At this point, I can keep left-clicking to place points, but I want a specific length for this line, so I'll need to undo the last few clicks. Since I haven't ended the command, using the general undo command from the quick access toolbar will just undo the line. Since the command is still active, I could press Ctrl-Z to access the command's undo function and undo the last line segment, but note that I could also access the command's undo function by clicking undo from the command line, typing the blue letter, U in this case, and pressing enter, going through the right-click shortcut menu, or pressing down to bring up the menu in the dynamic input prompt and selecting undo with either the arrow keys by typing the name or with the mouse. Once I'm back to a single point, I can lock in a distance by typing a value while the length is highlighted. For this lesson, I'll type 20, and now when I press Tab to highlight the angle value, you can see that the line is locked into its length. I can press Tab again to back and edit it, but for now, I'll set an angle value of -20 and press Enter to define the line. Note that the negative value was relative to the side I was on, so if I move the cursor to the opposite side of horizontal and type the same values, the line will be placed going the opposite direction. If instead of a length, you have coordinates you want to draw to, you can do so by typing pound and then entering the coordinates separated by a comma or tab. I'll type 3, 0, and when I press Enter, the point is placed at those coordinates in the drawing. I'll undo the placement, and this time type the @ symbol, and then 3, 0 once again. This time when I press Enter, the point is placed relative to the previous point instead of at those absolute coordinates. By taking advantage of the various input methods, you'll be able to draw accurately to whatever specifications you need. As you create more drawings, you'll find that the first way you draw something is rarely perfect, and some editing is usually necessary. Often these edits won't be too involved and can be done by directly manipulating the object you want with grips and placing them accurately using object snaps. In the drawing here, I have an arced door opening that I want to increase the height of by moving the arc up. To get started, I'll select the arc, and it highlights in blue with 4 square grips. The 3 along the length of the arc will move only that point, thereby changing the shape of the arc, while the floating grip at the arc center point will move the entire arc as is. Additionally, hovering over one grip, like the top one here, will show all grip editing options available. For this point, I can either stretch the point, which will move it like before, or adjust its radius. The endpoints of the arc, on the other hand, allow me to either stretch or lengthen the arc. Since I want to move the arc as is, I'll undo any changes. Click on the center point grip, and use dynamic input to move the arc 0, 2 units up. I now need to reconnect the vertical lines, so I'll select the left line and use dynamic input to move its top endpoint 2 units up as well. This could be repeated for the right line as well, but this time I want to show you how to use object snaps to accomplish the same goal of connecting the endpoints once again. To start, I'll make sure that the object snap drafting setting is enabled on the status bar. With that done, I'll select the line, click on the top grip, and move it up until I see a green square appear at the end of the arc. This square represents an endpoint snap, and as long as it is showing, we'll snap any click to that point. To show you what I mean, I'll move along the arc away from the endpoint and click. Even though my cursor was no longer at that point, it still placed it there. This can be frustrating if you're trying to place an object near a snap, but in those situations, it's a simple task to disable the drafting setting for a moment. In addition to helping with grip editing, object snaps can also be used when drawing. For example, if I wanted to add a line from the center of this arc to the midpoint of the bottom line, I can do so without even knowing their coordinates. I'll start by enabling the line command, and then hover over the arc to make its center point appear as a white cross. I'll hover over it so the center snap, a green circle, appears. Click, and move down to finish the line. When I hover over the bottom line, however, only endpoint snaps appear. To make a midpoint snap appear, I could turn the setting on from the drafting flyout. Or if I only wanted to use it for this instance, hold Shift and right-click to bring up the Object Snap Override menu. From here, I'll select midpoint, and now the only snaps that appear anywhere are triangular midpoint snaps. I'll select the midpoint of the bottom line, and I'm done. When you're starting a drawing and only have a basic idea of what you want to create, the precise input methods that we've covered so far can sometimes be a hindrance. For situations where you're looking to quickly draft freehand, or only need a little guidance, the OrthoMode and polar tracking drafting settings can be a huge help. These settings will affect how I can draw, so I'll start by enabling the line command and placing a point in the middle of the drawing area. With neither setting yet active, I'm free to move around the drawing area with no additional feedback. To change that, I'll go to the status bar and enable OrthoMode. The line that I'm drawing immediately snaps to an orthogonal direction, and as I move around the drawing area, you'll notice that the line is restricted to either vertical or horizontal, no matter where my cursor goes. I'll disable OrthoMode by pressing the F8 key, a hotkey listed if you hover over the settings icon, and I'm back to the normal full range of motion. This quick toggle can be a huge help when freehanding quickly if you're placing vertical or horizontal points. The next draft setting, polar tracking, is less restrictive and simply offers additional feedback. I'll turn it on from the status bar, and as I move around the drawing area once again, notice that green reference lines shoot out from the start point every 45 degrees. These lines act as a guide to help placing points at exact angles easier, and similar to snaps, will place the point along the line if it's showing, even if the cursor is slightly off of it. To change the guideline increment, you can either click on the flyout next to the setting in the status bar and change it from here, or click Tracking Settings to bring up the Drafting Settings dialog box. From here, you can both select a default angle or add custom angles of your own to track at. Object snap tracking is an incredibly helpful drafting setting used to draw relative to existing objects. It works by creating reference lines from existing object snaps that appear at specified angles. You can think of it as polar tracking from a specified object snap. To show how to use them, I'll move this hexagonal nut into the center of the square block here. I'll enable the Move command from the Modify panel, select the hexagon as the object to move, and right-click. I'm now prompted to specify the base point, which will be used as the reference when moving. Since I want the center of the hexagon to be at the center of the square, I'll need to select it as a base point. Unfortunately, there is no circular geometry here to generate a center snap point, so I'll need to track from existing snap points to find the center of the geometry. I'll make sure the Object Snap drafting setting is enabled, and hover over an endpoint at the left tip of the hexagon. After waiting a few seconds, I'll pull away, and a green tracking line appears intersecting with the snap I just moved away from. I'll pull off the line, and notice that the point I was tracking from now has a green cross, indicating that I can track from it. Notice as well that as I move around the drawing area, tracking lines appear every 45 degrees. This is because Object Snap Tracking uses the polar tracking settings. Though note that if I bring up polar tracking's tracking settings, I can use the Drafting Settings dialog box to set Object Snap Tracking to only track orthogonally from the selected points. Since tracking from only a single point won't let me find the hexagon's exact center, I'll need to activate an additional object snap to track from. I'll hover over the midpoint of the top line. And now when I move to the center of the hexagon, the cursor snaps to where the tracking lines intersect. I'll click, and the hexagon is now free to move with the cursor attached to its center. To finish the move, I could once again track from a pair of points and place the hexagon at their intersection. But since I know that all sides of the square are 6 units, I can use another method. I'll start by hovering over the top midpoint of the square to track from it, and then move down along the tracking line. Dynamic input updates to show the coordinates relative to the object snap. So when I type 3 and press enter, the hexagon is moved 3 units from the snap in the direction of the cursor, placing it in the center of the square.